So here I am explaining Coprocessor instruction. In the syllabus, it is under program status register instruction itself. Okay, it is a subsection of program status register instruction. But in exam, you can expect this as a separate question because these instructions have nothing to relate with your program status register. Okay. Now, basically, first of all, let me tell you what is coprocessor. So, processor, we know ARM is a processor. Okay, ARM is a processor. We can call it as a microprocessor or microcontroller. Okay, it is neither a processor nor a controller. So what is coprocessor? See, when ARM, I will explain in terms of ARM, in the perspective of ARM. See, when I say ARM processor, it has a particular number of instructions that ARM can execute. So what are the instructions indirectly? Instructions are nothing but it tells what are the capability of the processor. When you use add instruction, that means ARM processor is capable to make addition. When you use multiply instruction, ARM instruction is capable to multiply. So if there is an instruction, that means ARM is capable to do that task. Suppose if there is no instruction which you want in a processor, that means processor is not capable to do that particular task. Now what happens is when ARM is developed, so they develop it as a very general processor. Okay, and what happens is when that ARM has to be used in a practical environment, right? It has to be used somewhere, that ARM processor, okay, in any embedded system especially, okay, that ARM will be assigned to do a particular very specific task where ARM is not capable to do that. For example, I'll give one example. You might have studied about self-driving cars. So now these are electrical vehicles with self-driving car are trend, right? In the self-driving car, who actually handles the driving? Definitely processor. There is a processor which takes care of everything in the car, right? It reads exactly where road is going, what are the objects are in front of it. So entire thing a driver has to do will be done by a processor. Now imagine I am implementing an ARM processor to place it in a self-driving car. Okay, so I want my ARM to put a brake suddenly when there is an object in front of the car. Now putting brake, right, applying brake on the car is not a task that is capable by the ARM processor. Okay, just imagine ARM processor do not have any instruction, or I am talking about in a very broad category. If ARM processor do not have any instruction which programmer can use in order to apply brakes of the car when object is found in front of the car. So what will you do? We will make applying brake as a subsystem. Okay, we will implement some hardware, mechanical tools, motors, whatever things. We will make a small subsystem where by sending some signal, that subsystem applies brake of the car. Okay, so that is called coprocessor. Means ARM is not capable to apply brakes of the car, but ARM is only capable to identify object in front of the car and give signal to its coprocessor. So what coprocessor does? Coprocessor is we have implemented separately, very customized, which is to apply brake of the car, right? So that's called coprocessor. So what is coprocessor instructions? Coprocessor instructions means when processor is doing something and it needs coprocessor perform some task on the behalf of processor, processor has to communicate with the coprocessor. Either processor inform the coprocessor do something, or processor may request data from the coprocessor or result from the coprocessor. All those communications between processor and coprocessor are done using coprocessor instruction. Okay, so that's the meaning of coprocessor instruction. And what is a coprocessor? Coprocessor is a separate, dedicated or customized processor, a small processor which actually performs a particular task which is not done by the main processor. Okay, so what happens? So coprocessor, it provides additional computation capability. Correct? No, my ARM was not able to apply brake on the car. Now my ARM is able to apply brake on the car because I have attached a coprocessor. So that's called, it gives additional computation capability. And also most of the time coprocessors are used for managing memories. Okay, because memory itself is a big concept in your memory management itself is a very inevitable concept which has to be done every time, memory management. So for processor it will be a burden, okay, to take care of the memory. So we can have a separate coprocessor which take care of the memory, and processor can be reduced, right? The burden on the processor to manage the memory can be reduced. So that is the main use of coprocessor, to manage the memory, or we can attach additional functionalities to the processor. Okay, and what does actually coprocessor do? Coprocessor does same as main processor, that data processing operation, register transfer operation, memory transfer operations, but ultimately it will support all these operations: data processing, register transfer, memory transfer. All these operations will be combined such that coprocessor will basically perform a particular very specific task which cannot be done by main processor. Okay, so this is called coprocessor and coprocessor instructions. Okay, I am not always remember here, when I say coprocessor instruction, I am not talking about the instructions that can be executed by the coprocessor. No, I am talking about the instruction that can be used to make communication between main processor and coprocessor, so that main processor can inform coprocessor to do some task, or main processor can fetch data or result of the coprocessor. Okay, the instructions communication between processor and coprocessor. I am not talking about the instructions that coprocessor can execute. Okay, remember, that's very important. Now here there are basically 5 instructions. You can see CDP, MRC, MCR, LDC, STC. These are the 5 instructions they have discussed in the syllabus, and explanation to these instructions I am keeping very minimal, because even in the syllabus they have not discussed any instruction in detail. Okay, so that we can also avoid wasting of our time in the perspective of exam. Okay, when we read, so I am keeping all the explanation for these instructions very minimal. Okay, as exactly they have mentioned in the syllabus. So now the syntax, okay, of course you have to remember the syntax for the purpose of examination. If they ask explain coprocessor instruction, you have to write the syntax of 5 instructions. Okay, I will explain meaning of these instructions. Okay, but before that, in these instructions we have some terminologies. Let's see those terminologies. It is very important. See, in every instruction there are operand called CP. CP in the sense coprocessor identifier. Okay, because when processor wants to communicate with particular coprocessor, there will be n number of coprocessors. There is a possibility that there will be n number of coprocessor in around a main processor. So which coprocessor the main processor wants to talk, so that its ID is very important. Okay, CP means field represents the coprocessor number. Every coprocessor will have a number. Okay, so to whom we are talking, that must be written here, to which coprocessor we are making communication by the main processor. That's one important thing. Okay, then yeah, he says there is possibility of 16 coprocessors in ARM, P0 to P15. Okay, CP0 to CP15. Okay, 16 coprocessors. Then opcode in the sense, okay, then see every instruction has, most of the instructions, 2 instructions have opcodes here. Now what are the opcodes? Opcode describes the operation to take place on the coprocessor. That means when main processor informs a coprocessor using its ID here, right? When main processor informs a particular coprocessor using its ID or number CP, and informs what operation that coprocessor has to do, its opcode of that instruction which has to be executed by the coprocessor. Okay, that cannot be executed by main processor. That opcode, okay, very important. Okay, then CN, CM, CD, we have seen here CM, right? CN, all those things. These are the registers of the coprocessor. Okay, so how do a processor and coprocessor can communicate? How do these can send data from one place to another place, from processor to coprocessor or coprocessor to processor? How we can transfer data? Through registers. Okay, through registers, no other way. So that's why we know already ARM have a register from R0 to R15 registers. Similarly, coprocessor will have registers, its own register. We have represented using CN, CM, CD. you must note down this, that coprocessor operation, that opcode and registers, what are the CD, C and CM, they are purely depends on what type of coprocessor, right, we are referring to, because different coprocessor will have different names for their register, and different coprocessor will execute different opcode instructions. Okay, the different coprocessors are very specific, their instructions it executes are different from each other. Okay, so if generally we have written the CD, CN or opcode, okay, they completely depends on which coprocessor we are making use of. So I told you I will give a little I will explain what are the meaning of these 5 instructions which are used to communicate by the processor with coprocessor. So CDP means coprocessor data processing. Okay, this is the instruction main processor executes in order to inform the coprocessor to perform some operation, data processing operation inside the coprocessor. Okay, now which operation it has performed, that will be informed through the opcode of the opcode. So I will go back to my previous screen here. Yeah, here I am talking about first. Look at the syntax first. CDP. Okay, coprocessor data processing. Right, coprocessor data processing. I will inform to which processor has to do that operation and what data processing operation has to be done. Okay, so this is how main processor informs particular coprocessor to perform a particular data processing operation inside the coprocessor. Very important. Next instruction, 2 instructions. Okay, this is only direction changes. Coprocessor register transfer. Okay, it is just like MRS, right, and MSR. I explained right in my previous video. So MSR and MRS. So now here, similarly, MRC, you can understand M means move, then MCR. So very simple. C means coprocessor, R means regular register of the ARM, main processor register. So moving, we know direction, no? Right to left is always the direction of data transfer. So MRC means moving result or data from the coprocessor to any register of the ARM or main processor register. And MCR means moving data from main processor register, that is ARM register, to its coprocessor register, right, to its coprocessor register. That's why you can see, I'll go back again in this syntax. I'm talking about second instruction, these 2 instructions. So which processor we are communicating, okay, and its data transfer operation, register copy mode operation, and here we have this, right, okay, CD, CN, CM. Okay, this is how. So from either from coprocessor we will transfer it to regular processor instruction, that is ARM processor register, or from ARM processor we will transfer it to coprocessor. That is the meaning of MRC, MCR. So this is data transfer. And finally load and store, L and F. We know what is the purpose of load and store instruction. It is to communicate with the memory, not register. So coprocessor memory transfer. Coprocessor memory transfer. Load and store means load coprocessor means here loading block of memory from to a coprocessor. Okay, there from the main processor a block of memory. Okay, I'm not talking about register. I'm transferring a block of memory to coprocessor. Okay, that is called store. Okay, store. I mean that is storing. Loading. Okay, loading means copying from the coprocessor. Okay, block of memory we are copying from the coprocessor. That is okay, load. And store means from main processor we are copying block of memory to the coprocessor. Okay, this is the register transfer, this is memory transfer. This is register transfer and this is memory transfer. Okay, so here M means move, not M means not memory, M means move. This is register transfer, 2 instructions. Okay, why we have memory transfer and register transfer 2 in different instructions? It's the direction. Okay, from coprocessor to main processor or main processor to coprocessor. One example in textbook we have given. Of course, we cannot write an example for coprocessor instruction unless we make a in-depth study. But still, you remember this example in case if asked in exam. So let us see one coprocessor instruction. let me tell you, ARM or main processor want to transfer content present in coprocessor, okay, in its register C0. There is a C0 register in my coprocessor CP15. It is the number of the coprocessor. There is a coprocessor called CP15. There is a register called C0 inside the coprocessor, and ARM wants that register content to be loaded into R10, regular register of ARM. Main processor the register R10. So how to do it? MRC, right? Coprocessor to ARM register data transfer. Coprocessor to ARM register data transfer. That's the instruction. Correct? No, I am transferring from coprocessor register to the ARM processor register. Then opcode. Right, here is the CP number, so CP15. The CP15 or P, okay, P15 until no problem. Then we have to, this syntax is discussed in previous slide, right? Then opcode, okay, opcode we have written 0, okay, there is no instruction, which is just a transferring data from C0 to R10. Then destination R10, right, here we can see here R10, same instruction I have written twice. Then two register we have to mention. We mention both same register because we want to copy data from C0 itself. So both the register we have written C0. And then opcode 2 is also, there is no opcode. Okay. So this is the comparison of syntax and example. Okay. Copying data from C10 register of the coprocessor 15 into the R10 register of main processor ARM. So this is about the coprocessor instructions. So finally I'll tell once again, coprocessor instructions are not instructions executed by coprocessor. These are the instructions used by main processor to make communication with the coprocessor. There are three categories. The categories are, one is informing coprocessor to perform data processing operation, informing coprocessor to copy data from coprocessor register to ARM processor register, or from ARM or main processor register to coprocessor register. Then one more category of instruction is to transfer memory, block of memory from the main processor to coprocessor or coprocessor to main processor. So these are coprocessor instructions discussed in syllabus.